We're continuing our notes on solving systems of equations, specifically by substitution. We have solved by graphing. We have learned how to solve by substitution. We're going to take a look at a couple today that are a little bit different, although example 1 is pretty similar to the ones we did last class. Example 1, we're asked to solve the system by substitution, and we are given y equals 5x minus 2 and x minus 3y equals negative 22. So again, to substitute, we are going to take one of the variables, in this case y, whichever one says something equals something else. Y is equal to 5x minus 2. So we are taking what y is equal to, and we are replacing the y in the other equation. So I'm rewriting this second equation. X minus 3y equals negative 22. But instead of y, I'm putting in what y is equal to. Y is equal to 5x minus 2. That goes in for the y. I've got a number in front of a parenthesis. We distribute. So we have x, negative 3 times 5x is minus 15x. Negative 3 times negative 2 is positive 6. Combine any like terms we have. X minus 15x is minus 14x. And solve our equation from there. Subtract 6 from both sides. Negative 22 minus 6 is negative 28. And divide both sides by negative 14. Negative 28 divided by negative 14. Negative divided by negative should give us positive 2. There's our x value. Like always, we need to get our y value. We can do that by going back to either one of the original equations. Going to the y equals equation is going to be your best bet, and replacing x with 2. So it's going to say y equals 5 times 2 minus 2. 5 times 2 is 10, minus 2. I get y equals 8. X equals 2, y equals 8. Example 2 looks very similar. It's a little bit different in that there's one thing we need to make sure we're careful on one like this. So it says 5a minus b equals negative 1 and b equals 3a minus 1. 5a minus b is equal to negative 1. b equals 3a minus 1. We start the same way. We replace one of the variables with what it's equal to. In this case, we have an equation that says b equals. So I'm going to take 3a minus 1, and I'm going to put it in for the b. So it's going to say 5a minus b equals negative 1. Now, when we put it in for the b, a lot of times I see students do it like this. 5a minus, and b is this, equals negative 1. The problem is you always need to substitute in parentheses. I need to subtract all of b. So when we put in this 3a minus 1, it has to be in parentheses. And that is important because I have that minus sign right here. Remember, that's a minus 1. If there's no number in front of the parenthesis, it's understood to be a 1, or in this case, a negative 1. And now we need to distribute. So I've got my 5a, negative 1 times 3a, that's minus 3a. And negative 1 times negative 1 is positive 1. That should say, yes, minus 3a, but that's going to say plus 1. So it's always important when we substitute that we make sure we do so by plugging it in parentheses. Distribute that -1 and we're off. 5a minus 3a is 2a. Subtract 1 from both sides. Divide by 2. And once we have one variable, we get the other one by plugging -1 in for my a. Three times -1 is -3. Minus 1 gives us b equals -4. Example 3, again, solved by substituting. Y equals 9x minus 3 and y equals 2x plus 4. Again, looks a little bit different. This one's a little different in that both of the equations say y equals. When this is the case, it does not matter which one we substitute. We can either take 9x minus 3 and put it in for y here, and that will work. Or we can take 2x plus 4, that's equal to y, and plug it in here. Either one's fine. I circled it this way, so that's what we're going to do. So if I put 2x plus 4 in for the y, it says 2x plus 4 equals 9x minus 3. We now have our equation that we can solve. I don't have any parentheses. I don't need to do any distributing. I don't have any like terms that are on the same side. 2x and 9x are like terms, but they're on different sides of my equal sign. When that's the case, it's been a little while since we've solved an equation with variables on both sides. We need to move all the variables, all the x's, to the same side of the equal sign. So 2x and 9x, it's always easier to move the smaller number. So in this case, the 2x. I'm going to subtract 2x from both sides. Positive 4 equals 7x minus 3. And now we know how to solve. Add 3 to both sides, giving us 7x equals 7. And divide both sides by 7. X is equal to 1. As always, substitute back in to get the other variable. 2 times 1 plus 4. I get the solution 1, 6. I've been circling my answers like this. This is a perfectly acceptable way for you to do it. You could also write it as an ordered pair, 1, 6. We always put the x value first. Either this answer or that answer is acceptable. If you ever happen to see a multiple choice answer and this is the answer choice, make sure you know how to match this up with that. Example 4. Example 4, again, one that's a little different. X plus 2y equals 15, and 3x minus 4y equals -5. X plus 2y equals 15, and 3x minus 4y is equal to -5. I want you to think, first of all, how this one is different, and then how we might take care of that. What our first step might be on a problem like this. Notice none of the equations say x equals or y equals. All the x's and the y's are on the same side in this first equation. All the x's and y's are on the same side in the second equation. If that happens to be the case, we are going to solve for one of the variables in one of the equations. And the easiest one to solve is any of them that have a leading coefficient or a coefficient of 1. So I've got a 1x right here. So we're going to solve this first equation for x. So it says x plus 2y equals 15. We are going to subtract 2y from both sides. So it says x equals negative 2y plus 15, positive 15. We solved this first equation for x. It now says x equals. That's what we want. We want one of the variables by themselves. B equals. Y equals. Y equals. X equals is what I want. So now I can take it. I don't want to plug it back into the same equation. We want to plug in 4x into the other equation. So when we do that, it says 3 times x minus 4y equals negative 5. But instead of x, we're putting in negative 2y plus 15. And now we've got an equation. We should be able to solve this equation for y. It's going to take a couple steps, but we can get there. Distribute your 3. Combine your like terms. Negative 6y minus 4y. That's negative 10y. Subtract 45. And finally, divide both sides by negative 10. I get y equals 5. We can get x by plugging 5 into either equation. I'm going to go with the top one. X plus 2 times y equals 15. X plus 2y, I'm putting 5 in, 4y equals 15. 2 times 5 is 10. Subtract 10 from both sides. I get x equals 5. What? X equals 5, y equals 5. Couple more example problems. We are asked to solve by substitution. Notice again, none of the variables are by themselves. None of the variables, none of the equations say C equals anything or D equals anything. So we need to make an equation that says C equals or D equals. To think about which equation we would solve and for which variable. We always want to do the one that has a coefficient of 1. So we're going to solve this equation. We're going to solve for D. We can do that by subtracting 2c from both sides. D equals 7 minus 2c. This equation now says D equals, so we can replace this D with 7 minus 2c. 4c minus 2d equals 18. Instead of D, we are putting in 7 minus 2c. Distribute. I have negative 2 times 7. Negative 2 times negative 2c. Negative times negative is positive. 2 times 2 is 4c. 4c and 4c make 8c. Add 14 to both sides. +18 plus 14 is 32. and divide both sides by 8. C is 4. Plugging in 4 for my C, right here would be easiest. 2 times 4 is 8. 7 minus 8, D equals negative 1. One last example problem, example 6. We have m equals 3n plus 2 and m equals 2n minus 9. M equals 3n plus 2, m equals 2n minus 9. Start by substituting. This is one where both equations say m equals m equals. So I'm going to take 3n plus 2 and plug it in here. With n's on both sides, we need to move them all to the same side. We can do that by subtracting 2n. 3n minus 2n, that's 1n. And subtract 2. N equals negative 11. Substitute that back in. M equals 3 times negative 11 plus 2. 3 times 11, that's 33 positive times negative. Negative 33 plus 2 is negative 31.